Hello, we are just going to do one example today of basically the second half of our differential equation problem. So this is after we've already performed our Laplace transform, gotten our f of s, we're going to do a little partial fraction decomposition in order to be able to do our inverse transform. And I just thought we would do that, and then you would have the rest of the day to kind of work on the assignment, do the practice problems, all that good stuff. So this one is a little bit more like a traditional partial fraction. And the first thing we're going to do is we're going to go ahead and factor the denominator. We do get a trinomial here that factors nicely, so we don't have to do any crazy algebraic manipulations like we've had to do with some of the other examples that I've shown you. But what this does give us is three factors, which means that we are going to break this up into three fractions, a over s, b over s minus 7, and c over s minus 1. And so for this, we did do a problem like this a little bit earlier on, and we saw that we have to take this, multiply by our lowest common denominator, which would be that s times s minus 7 times s minus 1. And upon distributing that, we would get basically every factor other than what's in the denominator is going to be present. So a times s minus 7 times s minus 1, since the s's cancel, and then b, the s minus 7s would cancel, so we get s times s minus 1. And then c times s minus 7. I solved this as a traditional system of equations in the last example we did. What I wanted to do here is we're going to go ahead and remember we still have our numerator. So we set this equal to that 6s squared minus 21s plus 21. I guess I probably should have included that when I was doing my multiplication here, that we're multiplying this whole thing. There we go. That's a little more accurate. So instead what I want to do is use the idea here of smart s's. So basically trying to use a value for s here, which would get some factors to go to 0, and then that would cause my term to go to 0. So the first and easiest one to do that would be a smart s is if s is equal to 0. If s is equal to 0, this whole term becomes 0, this whole term becomes 0. So in that case, I would get a times negative 7 times negative 1, and then, oh gosh, where did my work go? On this side over here, that each of these terms would also cancel and give me 21. So this one's nice because this is just saying 7a is equal to 21, which means I've already solved for one of my numerators. A is equal to 3 here. So that's nice. Another smart s would come from this factor of s minus 1. So I want to figure out what's going to happen if s is equal to 1, because this term right here is going to cancel, this term right here is going to cancel, and that leaves me with this right here. So it looks like we're going to have c times 1 times negative 6. Over on this side over here, we are going to get 6s squared, which is 6, minus 21 plus 21. Okay, a little cancellation there. So it looks like here we get a negative 6c is equal to 6. So pretty sweet here. C equals negative 1. Good place to be. Now let's do our last smart s. So let's say if s is equal to 7 from this factor right here. And so this term go to 0. This term over here would go to 0. It looks like we're going to get b times 7 times 6 is equal to, I did a little bit of this math already, so this term right here gives me 294, the 6 times 49 right here. And then 21 times 7 would give me 147, and then I have this plus 21 at the end. So simplifying that a bit gives me 42b is equal to 168. And if that's the case, then I can solve and b equals 4. So we actually didn't have a lot of complications. with solving for A, B, and C here, which is nice. That doesn't necessarily happen all the time, but that happened this time. So let's go back to, what we had up here. I'm going to go ahead and just bring this down since we now know what A, B, and C are. And I'm going to go ahead and rewrite this. So we have A over S, which is 3 over S. Oh, goodness. Let's try an S instead of an 8. There we go. And then we are going to have B, which is 4 over S minus 7. And we are going to have C, which is that minus 1 over S minus 1. Okay, and keeping in mind this is our capital F of S. So what we did here is we did all this algebraic stuff that we've learned in the past, but we've made hopefully something that's a little bit easier to take the inverse Laplace of, because again, that's the whole purpose here, is that we're doing this so we can have something that's easier to perform an inverse Laplace on. So we're going to do that. We're going to take the inverse Laplace of 3 over S. I don't know why I keep doing that. 3 over S. And then, this is a nice transformation here. You know what I actually could have done is said that we were taking the 3 times the inverse Laplace of 1 over S, because that one is a nice one. I mean, if you can just see it, you don't have to separate them out like that. If you can see that 1 over S is just going to give you 1, then great, if you recognize that. So if I do that, 3 times the 1 that I get from my inverse Laplace here gives me 3. Okay. We could also pull the 4 to the front here if we want and take the inverse Laplace of just 1 over S minus 7. This right here is that S minus alpha. So it looks like alpha is equal to 7. And if I perform my inverse Laplace and multiply it by 4, it looks like I'm getting 4 times e to the 7t. All right, and then last, we could do our -1 as our constant here, multiply that by the inverse Laplace of 1 over S minus 1. Again, this is just a shift. And so my shift here, alpha is equal to 1. And I multiply that by the constant of -1. So that'd be -1 e to the t. Okay, so there's my function for f. So let me just write it down here. F of t, lowercase f of t, after performing my inverse Laplace, is going to be 3 plus 4 e to the 7t minus e to the t. And essentially, if we're solving a differential equation, that this would be one of our solutions for y of t, or in our case, we used f of t. Hope that helps, and good luck today with that assignment. Again, as always, let me know if you need any